Okay, we're moving on. We're going to be on page 54. We're talking about functions, and we're going to start with problem number 47. So on number 47, they give you a function, capital F of x equals 2x cubed minus x squared plus 3, and they ask you for the domain of the function. So when we're talking about domains in this class, the thing that we're really concerned about is, will our function ever have division by 0, or will we ever have like a square root of a negative number? And in this case, we don't even have a fraction. Okay, we don't have our x ever in the denominator, so we can't ever get division by 0. And there's no square roots, so we can't ever get a negative number under a root. So this is actually a very, very well-behaved function. We can plug any number we want into this. So our domain is all real numbers. And the way we would say that is that our domain is everything from negative infinity to infinity. And I'll put here x is an element of this interval. So any x that we could ever think of, we could plug in there and we don't have any problems. Now let's compare that to number 49. Number 49, little f of x is equal to x minus 2 over x plus 4. So in this particular problem, we do have a problem. Okay, we're asked for the domain again. And what we know is that we can't have this be 0. If that's 0, that's a bad thing. So that's what I'm gonna write down here. Look, x plus 4 can never be 0, or else we get division by 0. And if we subtract 4 on both sides here, what we're saying is x cannot be equal to negative 4. So we want to throw that number out. But every other number that we could ever plug in here on the bottom is going to be okay, except this. So how do we say that in our interval notation? Well, here's our number line, here's 0, here's negative 4. And we don't want that one, so I'm going to put an open circle. It's everything to the left forever, everything to the right forever. And so the way we're going to do that with interval notation is to come up with two intervals. One of them is going to be everything to the left of negative 4, everything's to the right of negative 4. So I put x is an element of the interval negative infinity to negative 4, putting a parenthesis on negative 4, which means I do not include negative 4. So it's kind of like we're going to go everything out there all the way up to negative 4 and then jump over negative 4, so union, and then go from negative 4 and continue on to the right forever. So from negative 4 forever this way. So that's our domain. 51. All right, g of x equals square root of 7 minus x. So now we have a square root, and what we know for square roots is that this thing under here cannot be negative, right? It cannot be negative. We call that, by the way, the thing underneath the root, we call that the radicand. Radicand. The radicand can't be negative, which means the radicand has to be greater than or equal to 0. That's what we need in order for this function to work. So that means 7 minus x has to be greater than or equal to 0. And to solve this linear inequality, all I'm going to do is add x to both sides. And that will get x by itself, and it will also create a positive x. So cancel that, 7 greater than or equal to x. So that is my set of x's that'll work. But let's try and understand what this is. So on a number line, here's 0, here's 7. My x's must be smaller than or equal to 7. So smaller than 7 means to the left of 7. So anything over here will work. And 7 itself does work, so I need to include it. That means you can put a bracket if you want. And over here, well, no, that was a different type of interval, so never mind. So for this one, solid dot, that's fine, or some books they use brackets. Either way, understands everything to the left of 7, including 7. So I'm going to say everything to the left of 7 is negative infinity all the way to 7, and then I put, very important, I put a bracket here instead of a parenthesis because I want to include it, and then x is an element of that. So that's the answer. All right, moving along. For number 61 through, we're going to do number 61, 69, and 73. 61, 69, and 73 all have to do with the same function. They give you a function, they ask you to evaluate it at different places. So let me start off by writing down what the function is that they want you to work with here. They want you to work with the function f of x equals x squared minus 4. So for number 61, they just want f of 4. So that means I'm just going to replace this with 4, which means replace that with 4. So it becomes 4, notice it's in parentheses, squared minus 4. The reason why I want to put it in parentheses is because if this was negative, then that would be negative, and you would square negative, it would become positive. So just be careful with that. In this case, it's just 4. So 4 squared is 16. 16 minus 4 is 12. Okay, so we're done there. Answer's 12. Now for number 69, they want us to evaluate f of 2 plus f of h. Okay, well, these are two separate things we have to do. First, we have to plug 2 into the function. So let's plug 2 into here. We would get 2 squared minus 4. Okay, so that is this. Then plus, now we need f of h. That means we replace this with h, replace that with h. So what we will get is h squared minus 4. So this right here is that. Now 2 squared is 4. 4 minus 4 is 0. So all of that's just 0. So all you're left with is this. So your answer is h squared minus 4. Notice it's not a numerical answer. You have a variable in your answer. And that's okay, because you had a variable being plugged in. It makes sense that you would get a variable on the output of this function. All right, let's look at number 73. I'll erase these. So for 73, they want f of 2 plus h minus f of 2. Good. All right. So for this one, we have something interesting happening here. We're actually going to be replacing this x, which means replace that x, with this binomial, two terms, 2 plus h. So that 2 plus h, when it goes in here, has to be squared. So the way I write this is going to be very important. I need to replace that with 2 plus h in parentheses, and I need to square it. Then subtract 4. So this is this piece right here. Okay? Then I need to subtract f of 2. And be very careful here, because plugging 2 into here, we already did that earlier, but since we're subtracting it, not adding it, I need to kind of put parentheses here in case there's more than one term that negative will distribute through. So when we plug 2 into this, we got 2 squared minus 4. Now it's going to turn out that this is 0 and that minus is not going to matter. But let's say this had turned out to something different. That negative would have to pass through. So this is 0. So we don't need to worry about it. And then this right here is the result. Okay, this is our answer. Now, that's fine as an answer, but because of what we're going to be doing later, let's go ahead. I want us to just practice expanding this. Remember, 2 plus h squared means 2 plus h times 2 plus h. And then you have to FOIL. So 2 times 2 is 4. 2 times h is 2h. And then h times 2 is another 2h. And then h times h is h squared. These two are like terms. Put them together. 4 plus 4h plus h squared. So that's what we get when we put this all together, or square that right there. So let me go ahead and place that here. We have 4 plus 4h plus h squared. That's just this. And then we still have minus 4. And notice that these 4's cancel. And what we're left with is 4h plus h squared. Now again, this would have been okay as an answer, but later on for what we're going to be doing, we want to be able to get it all the way to here. So I want to just show the mechanics of that, and that's it. Okay, so we're moving on to numbers 75, 77, and 79. For number 75, 77, and 79, they ask us to find three different things. I'm going to write it down over here. For part A, they want to know what f of x plus h is. For part B, they want to know what f of x plus h minus f of x is. And then for part C, they want to know what f of x plus h minus f of x all over h is. All right. Now, in 1324, you were probably shown this, especially this right here. This is known as the difference quotient. Very important in this class. Okay, the difference quotient. So I'm going to skip parts A and B for these because to do part C, you have to be able to get this, which is that. And then you have to be able to get the whole thing up top, which is this, and then just take it and divide it by h. So I'm going to do all of this kind of in one fell swoop here. So here's the function they give us, 4x minus 3. F of x is 4x minus 3. All right, let's see what kind of colors I have in here. I only have two colors. So I have blue and green. So I'm going to first do this piece right here. So what happens when I plug x plus h into this function? So if I replace that with x plus h, that means replace that with x plus h. I'm going to get 4 and then parentheses x plus h. Very important that the parentheses is around x plus h because the 4 has to multiply through to both things. Then I still have minus 3. Okay, so that is this part right here. Then I have a minus sign. So here's my minus sign. And then I have this piece, f of x, and this is not a very good marker. Let's see if I have a different color. I don't. Hang tight. Okay, got some other colors here. See if this is any better. All right, so I am doing f of x right there. So f of x is the easy one because you're just going to write this down. So I'm just going to write down 4x minus 3. But the minus sign is critically important. You understand that because you have two terms here, you must put this in parentheses so that the negative will distribute through. That's the big mistake I see students make, is they forget that part. So then you put all of this, right, over h. And you don't have to do anything, just write the letter h down. Okay, now let's clean this up. So what I'm going to do is distribute the 4 through. So I get 4x plus 4h. Then minus 3, then distribute the negative through here, you get minus 4x, then you get plus 3, and then all of this over h. Now, hopefully in your 1324 class, your instructor told you that if you do the difference quotient correctly, then you should be able to clean this up, and when you're done, the numerator should have nothing but terms that have h in it. So there should be nothing left up here that doesn't have an h. I'm confusing you. All right, I'm sorry. Look, 4x goes away, 4x goes away. The negative 3 and the positive 3 cancel. And notice the only thing left has an h in it. And that's what you should get every time you do this. You should get something like that to happen. All right, so on top I have 4h, and on the bottom I have h, and these h's can cancel, and your answer is 4. And that is it. So the difference quotient for this one is 4. Let's move on to the next problem. It's just a different function. That's all they do, is give you a different function so that you can do the same exact computation or use the same formula. So the function they give you for number 77 is the function 4x squared minus 7x plus 6. 4x squared minus 7x plus 6. I like this one. This is a good one. This is test problem right here. All right, so let's go through this part right here. So the first thing I've got to do is this blue one, which means I need to plug x plus h in to this function. Everywhere I see an x, replace it with an x plus h. So I'm going to have a 4. I'm going to have in parentheses x plus h, that quantity squared, because that's what it means, right? Take whatever you're plugging in and square it. That's what I'm plugging in, I'm squaring it. Minus 7 times, now instead of x, x plus h. So parentheses, x plus h, because the 7 must pass through to each one. Then plus 6. Plus 6 is just plus 6. So I'm done with this top left corner. Now minus. And then I need this part in green. And the part in green is just f of x, which is just rewrite that. However, because I have more than one term, I need it in parentheses. That way that minus sign will distribute. Then I take the whole thing and divide it by h. Okay, we've got some work to do here. I think the distribution of the negative through here is pretty straightforward. Signs are going to change. I think the negative 7 going through here is pretty straightforward. The only thing that's kind of really tricky is this part right here. So let's remember order of operations. You do not multiply the 4 through before you do exponents. You have to do the exponent first. So I need to square x plus h. I will do that up here. X plus h times x plus h. And I start my FOIL. X times x is x squared. X times h is just x times h. And then h times x is still x times h. It doesn't matter if I write that in this. Multiplication can be flipped around. So I just flip the order around so that these look exactly the same. And then h times h is going to give us plus h squared. So put those two together and you're going to have 2 of them. So I have this part right here that's being squared is going to be all this put together, but I still have a 4 out front. So I'm going to put 4 parenthesis x squared, these two guys plus 2xh plus h squared. Okay. Then I'm going to distribute this negative 7 through, negative 7x, and then negative 7h, so negative 7 goes to both. Plus 6 is still there. I'm going to run out of room maybe. Let's see, now my minus through here. So minus 4x plus 4x squared, minus 4x squared, plus 7x, and then minus 6. And then all of this is divided by h. We're almost there to the point where we can start canceling things, but let's distribute this 4 through to those 3 terms. So I will have, let's see here, 4x squared plus 8xh plus 4h squared, so that's my 4 going through, minus 7x minus 7h plus 6 minus 4x squared plus 7x minus 6. all over h. And now things should start to cancel out here. Let's see, we've got 6's are gone, negative 4x squared and positive 4x squared, 7x and negative 7x. And that's it. Nothing else is like term. But notice that everything that's left, which is this, this, and this, those all have an h in them, which is good. Let's see where we go from here. Okay, so from here, I have 8xh. I have plus 4h squared. It's this. I have minus 7h. And that's it on top, and on the bottom I have an h. Everything has an h on the top. So what I'm going to do is factor an h out. So if I pull an h out of this one, I'm just going to be left with 8x. If I pull an h out of this one, I'm going to have 4h, so I'll still have a single h there. If I pull an h out of here, I'm going to have just minus 7. And then that's all over h, and these h's cancel. And that's what we want to happen. And all that's left is this. So 8x plus 4h minus 7. So check this out. That's our answer. It looks kind of ugly, but that's our answer. Notice in the previous problem, our answer was 4, right? It was 4. But in this problem, it's some weird, crazy thing. We have 2 variables in here. That's all right. That's going to happen sometimes. All right, 79. Different function. The function is x, and then in parentheses, 20 minus x. And we're going to evaluate the difference quotient on this one. Okay. Now, your temptation here is to just go and replace this with x plus h and that with x plus h to get this top left corner. My advice would be that if you have parentheses in your original function like this, go ahead and just distribute this through now. That's 20x minus x squared. It's just a little easier to work with this than it is to work with this once you start trying to plug in x plus h. So I'm going to be focusing all my attention on this. So this is equal to, now let's do that top left corner. Let's replace x here with x plus h. So in parentheses, because that 20 must distribute through, minus, now x is replaced with x plus h, and squared, so it's in parentheses also. Then I subtract from that, subtract f of x, which is just going to be this thing written again, but in parentheses. 20x minus x squared. Then everything I have there over h. All right, I should be able to pass this negative through without any issues. I should be able to pass the 20 through without any issues. Here I have a minus, and I've got to square that. Now I did that already on the previous problem. When we square that, we got x squared plus 2xh plus h squared. I'm not going to show that again because I already did that. So just remember that you have a minus in front of all of this, so I'm going to put it in parentheses. Let me go ahead and show you. I'll leave the 20. I'm not going to pass it through yet. I'm just going to show you that this minus, I need all of this stuff in parentheses. X squared plus 2xh plus h squared. Okay, so that's that. And then I have minus parentheses 20x minus x squared. Then all of this over h. Now let's go ahead and pass things through. So 20 goes through these two. 20x plus 20h. Negative goes through to those 3 terms, so it makes them all negatives, or minus. Negative goes through those 2, so it makes it minus 20x and plus x squared. And then all of this is divided by h. And we should start getting some good cancellation here. I see my x squareds are gone. I see my negative 20x and positive 20x are gone. Nothing else can cancel. So all I'm left with is this, this, and this on top. And again, They all have h's. I'm not going to need this formula anymore, so I'm just going to continue this over here. So I'm going to have 20h on top minus 2xh minus h squared all over h. Since all of these have an h, I can factor an h out of the top. So let me move up. This will be equal to h comes out. I have a 20 here. I have minus 2x here. And here I pulled one h out, so I still have one factor of h there. And then all over h, cancel, and you're left with just this, 20 minus 2x minus h. All right. That does it for this section. That's the only homework out of here.